Very good morning, friends. We were dealing with the merits and demerits of microwave synthesis. It has its own advantages of increasing the reaction rate enormously, getting the selectivity of regio-wise selectivity, stereo selectivity, and so on and so forth. But it has its own limitations too. But however, in spite of all the limitations, they are overcome by modification in the synthetic methods. Instead of using solvents, neat reactions were carried out or clean reactions were also carried out, making it more eco-friendly, contributing to the green synthesis. Today's subject of discussion is applications of the microwave synthesis. Various heterocyclic compounds have been synthesized by using microwave heating. First and foremost is pyrrole synthesis. Here, 2,4-diketones were treated with various ara-alkylamines and irradiated with microwaves at around 100 to 200 watts, and the reaction is carried out without any solvent in a neat manner, and the reaction completed within zero point 0.5 to 2 minutes, which took several hours in the conventional method. Imidazoles were synthesized by using microwaves, an aldehyde and 2,3-diketones in the presence of aluminum oxide as catalyst and ammonium acetate. Ammonium acetate reacts with the diketones to give corresponding diimines, which in turn reacts with aldehydes to give rise to cyclized and aromatized product, that is imidazole. The reaction mixture was carried out under solvent free condition in a neat manner, and it was irradiated at 130 watts, and the reaction took 10 minutes for the completion, and the yields were in the range of 75 to 85%. Now you can appreciate the beauty of microwave assisted synthesis, which takes several hours, can be completed in few minutes, if possible few seconds, and the reactions are clean with less byproducts, and hence the percentage of yield will be also improved. Not only the good percentage of yield it can be achieved, and it can be achieved under solvent free conditions, which adds to the economy of the synthesis. The benzyl hydrazine was irradiated with cyclohexanone for 30 seconds. It cyclized to give the corresponding heterocyclic moiety. Here, in the conventional method, it took 2 hours for the completion of the reaction. The Fischer-Indole synthesis rate of reaction was increased 100 folds. Flavones were also synthesized where the beta-diketones were treated with K10 clay, Mount Morillonite clay, and irradiated for 1 to 2 minutes. It got cyclized to give corresponding flavones. Flavonoids has its own utility in the field of medicinal chemistry. In the conventional method, they used concentrated sulfuric acid and acetic acid mixture as dehydrocyclizing agent. This hazardous reagents like sulfuric acid can be avoided by microwave method. This is another advantage of microwave synthesis, which you can appreciate now. Further, this has also been utilized for carrying out oxidation reactions. Oxidation reactions generally use harsh reagents that can be avoided, or if not, we can reduce the amount of usage, reduction in the usage of solvent or reduction in the usage of reactant can be achieved by microwave synthesis, which we have studied, and we can see the example over here. The selective and solvent-free oxidation was carried out with clefen. Clefen is nothing but ferric nitrate. The alcohols, a secondary alcohol, was treated with clefen without any solvent in the equimolar quantities and irradiated for 50 to 60 seconds, and the secondary alcohol get oxidized to ketone with 87 to 96% yield depending upon the R1 and R2. Generally they are aryl derivatives. Further, the activated manganese dioxide and silica gel was used, and the secondary alcohol was converted into corresponding ketone by irradiating with microwaves within 20 to 60 seconds. The same results were achieved by using a different oxidizing agent, manganese dioxide silica gel. The yield here achieved was 67 to 96%. Oxidation of aryl compounds was carried out with potassium permanganate and alumina combination. The potassium permanganate and the aryl compounds were dissolved in a suitable solvent and coated onto the alumina. And after coating, the mixture was irradiated with microwaves, and this got oxidized to corresponding ketone. And this reaction was achieved within few seconds. Various rearrangements were also carried out utilizing microwave synthesis. Pinocol-pinocolone rearrangement is one of the rearrangement which was tried out. The pinocol-pinocolone rearrangement, we use an acid. Here we use aluminum ion with Mont Morillonite clay and irradiated over 15 minutes. It gave the corresponding ketone with 98 to 99% yield. That is the salient feature of this pinocolone rearrangement using microwave method. Further, Beckmann rearrangement was also carried out using the same Mont Morillonite Caton clay, where the oxime was taken and in the presence of Mont Morillonite Caton clay, it was radiated for 7 to 10 minutes. It gives the rearranged amide, which took several hours in the conventional method, could be completed within few minutes. No-Vinegal condensation was carried out by using microwaves to get coumarins. Orthohydroxybenzaldehyde derivatives were taken and treated with various alkyl ethyl acetates in the presence of a base like piperidine. When it was irradiated with microwaves, it got cyclized to give coumarins within few minutes. This is all about the few of the applications what we have dealt till date. There are enormous reactions were carried out, and it has been reported in the literature since long, since last 20 years. What cannot be achieved by conventional method can be achieved by microwave method. The reactions which took several hours can be accomplished within few minutes, if possible within few seconds. Further, yields of the reactions where products can also be improved. The regioselectivity, stereoselectivity can also be achieved in many of the cases. There are enormous number of examples in which microwaves are utilized for carrying out the synthesis, not only at the lab scale but also at the industrial scale. Monomode microwaves have come as a boon for the synthesis of enormous types of compounds, starting from heterocyclic to organic to the proteins synthesis. Thus, we have to utilize microwaves wherever possible and get the better yield and contribute to the field of chemistry. Hope this lecture will help you or make you think to utilize the microwaves for the synthesis and you achieve and contribute in the near future. Think over it, design, implement, and contribute to the field of chemistry. All the best. Thank you.